What if I told you everything you've ever known, that every star in the night sky, every planet, every molecule, every memory, could one day vanish into cold, silent nothingness, not through war or plague or planetary disaster, but because the universe itself reaches an end, not the end of a civilization or a species, but the end of everything. It's not just science fiction, it's a question physicists and cosmologists are grappling with right now. Could humanity survive the end of the universe? Now take a moment to really think about that. Not just the end of Earth or our Sun or even the Milky Way galaxy. We're talking about the disappearance of every speck of matter, every force, even time itself. It's the kind of question that stretches the limits of imagination, and yet it's grounded in real modern science. Behind telescopes and particle accelerators, in complex equations and cutting-edge simulations, scientists are uncovering clues about how our universe might end, and whether anything can live beyond it. So why does this matter? After all, none of us will be around in 1 billion years, right? But this question reaches beyond time. It forces us to confront what it truly means to exist, what role we play in the cosmic tapestry, and whether intelligence, consciousness itself, has a fate beyond the stars. If there's even the faintest chance we can survive the universe's end, doesn't that make us the architects of something eternal? Before we dive deeper, let's pause for a moment. If you've made it this far, you probably have that same spark and that craving for wonder, that hunger to understand the cosmos. You're part of a rare breed, the cosmic dreamers. And we need each other to explore these mind-bending ideas together. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. All right. Let's begin by zooming way out, beyond the galaxies, beyond the cosmic web, and take a closer look at how this all began. The universe started with a bang, literally. The Big Bang wasn't just an explosion in space, it was the expansion of space itself. 13.8 billion years ago, everything, time, matter, energy, space, exploded outward from a single point of incomprehensible density. In a fraction of a second, the universe expanded faster than the speed of light, giving birth to the cosmos we live in today. But from the moment it was born, it's been changing, evolving, and moving towards something. For centuries, scientists assumed that gravity, the attractive force between matter, would eventually slow this expansion down, maybe even reverse it. But in the late 1990s, something shocking was discovered. The universe isn't slowing down, it's accelerating. Galaxies aren't just drifting apart, they're racing away from each other, faster and faster with every passing moment. What's causing this? The answer lies in one of the most mysterious phenomena in all of physics, dark energy. We don't see it, we don't understand it, but we know it's there because it's pushing the fabric of space itself apart. It makes up nearly 70% of the known universe, and yet we don't even know what it is. Think about that. The majority of the cosmos is made of something we've never seen, never touched, and barely understand. And it might be the force that dictates how everything ends. Depending on how dark energy behaves in the future, the universe could meet several different fates. The most widely accepted theory right now is the Big Freeze, also called the heat death. Imagine a future where all the stars in the universe have burned out, where black holes have slowly evaporated through Hawking radiation, and where galaxies are so far apart that light itself can no longer travel between them. The universe becomes a vast, empty void, a place without light, without warmth, without motion. A cosmic graveyard where nothing happens forever. But that's just one possibility. There's also the Big Crunch. In this scenario, dark energy doesn't win in the long run. Gravity does. The expansion slows, then reverses, and everything starts falling back in on itself. Galaxies crash together, stars explode, and eventually the entire universe collapses into a single point, just like it began. Some scientists believe this could lead to a cyclical universe, where each collapse is followed by another Big Bang, birthing a new cosmos again and again in an endless loop. a cosmic heartbeat. Then there's the Big Rip, and this one is horrifying. Imagine dark energy doesn't just continue accelerating expansion, it accelerates at an increasing rate. Eventually, even galaxy clusters can't hold together. Then galaxies break apart. Then solar systems, then planets, then molecules, then atoms. Even space-time itself begins to unravel. In the final moments, even the fundamental forces of nature dissolve. Reality disintegrates. Some models say this could happen in 20 billion years. Some say less. Some even argue we wouldn't see it coming until it was already too late. But here's the twist. Even if the universe dies, must we die with it? Think about humanity's story so far. We've evolved from stone tools to space stations in just a blink of cosmic time. We've cracked the code of DNA, split atoms, and peered across billions of light years into the past. And this is just the beginning. Who's to say what we'll become in another million years? Or a billion? Could we build technologies to escape a dying universe? Could we find or even create new universes to migrate into? Could we master space-time, tap into the quantum fabric of existence, and punch through to somewhere beyond our own dimension? These aren't just dreams. Some of the world's leading physicists are already theorizing about cosmic wormholes, vacuum decay bubbles, and even artificially generated baby universes. And here's the most incredible part. This isn't just about science. It's about hope. It's about the idea that life, intelligence, and consciousness don't have to be accidents of chance doomed to vanish. Maybe, just maybe, we're meant to outlast our universe. In the next section, we're going deeper, because before we talk about surviving the end, we have to understand what tools we might have to do it. What kind of civilizations could even attempt to challenge the end of time? What technologies could harness the energy of stars, galaxies, even black holes themselves? So if humanity were to survive the end of the universe, what would it actually take? Let's be honest. Right now, we're not even close. We're still learning how to harness clean energy on our own planet. We struggle with climate change, conflict and scarcity. Our greatest technological achievements, space telescopes, fusion experiments, artificial intelligence, are just baby steps. But if we're going to talk about surviving the death of the cosmos, we need to think far, beyond where we are now, into the realm of civilization types that only exist on theoretical scales. Let's begin with something called the Kardashev scale. Introduced in 1964 by Russian astrophysicist Nikolai Kardashev, this scale attempts to measure a civilization's level of technological advancement based on the energy it can access. It's divided into 3 primary stages, and what lies beyond those is nothing short of mind-blowing. A Type I civilization can harness all the energy available on its home planet. That's wind, solar, geothermal, oceans, lightning, every bit of power Earth has to offer. To give you a sense of scale, humanity today is somewhere around 0.7 on this scale. We're not even at Type 1 yet. But we're inching closer, slowly. A Type 2 civilization can harness all the energy of its star, not just through solar panels, but by building megastructures like Dyson spheres, hypothetical constructs that surround a star and collect nearly all of its energy output. Imagine the power of the sun, every ray of light, every flare of heat, channeled into sustaining life, computation, or propulsion. And then there's the leap to Type 3, a civilization that controls the energy of an entire galaxy. Billions of stars, black holes, supernovae, all accessible, manageable, and integrated into one vast network of intelligence and power. At this stage, civilizations may not even resemble biological life anymore. They could be machine-based, post-biological, or something we can't even conceptualize, existing across dimensions, communicating through gravitational waves, operating across light years in unified consciousness. But how would such civilizations survive a universe approaching its end? Let's say we're facing the big freeze, the long, slow, cold death of all matter and energy. A Type 2 or 3 civilization might have centuries, even trillions of years to prepare. They could store energy in massive battery systems, slow down time for themselves through relativistic travel, or even migrate toward regions of space still rich in matter, like galactic cores or deep space reservoirs. Some theories suggest these civilizations could build computronium spheres, planet-sized machines made entirely of matter, optimized for computation, capable of running entire digital civilizations in ultra-efficient slow-time states, essentially living forever, in simulation. And what if the end was more violent, like a big rip? Here survival becomes far more speculative and far more extreme. One concept proposed by physicist Max Tegmark is that advanced civilizations could begin constructing baby universes, new regions of space-time with different physical constants, created through manipulation of quantum fields or vacuum energy. These could be born in particle accelerators or engineered through black hole manipulation. Some even hypothesize that black holes themselves might be gateways to new universes, embryonic cosmos forming from the singularity within. This raises her tantalizing idea. What if we weren't the first? What if our universe was itself a child of another universe, seeded by an ancient civilization trying to escape their own cosmic death? It sounds outrageous, but there are physicists seriously exploring the possibility of cosmological natural selection, where universes capable of spawning life and intelligence become more likely to survive and reproduce through such mechanisms. But let's not get lost in pure theory. There are still other, more grounded paths worth imagining. A civilization advanced enough could attempt to manipulate space-time itself. Using what's called negative energy density, some theories propose the creation of traversable wormholes, shortcuts through space-time that could allow civilizations to move vast distances or even exit our universe altogether. These aren't just sci-fi constructs. They arise from solutions in general relativity, though we've yet to find a way to stabilize or control them. If wormholes are possible, then the door opens to something even more profound: inter-universal travel. Imagine escaping the dying universe not by resisting it, but by stepping outside of it entirely, into a parallel reality. A fresh beginning. Now let's take this idea one step further. What if, instead of fleeing the end, a civilization learned how to reshape the universe? Some theorists suggest that a truly advanced intelligence might be able to alter the very laws of physics, manipulating constants like gravity or the strong nuclear force, rewriting the cosmic code like a programmer, altering the parameters of a simulation. That might sound like divine power, but to a civilization millions or billions of years beyond us, who's to say what's possible? But let's bring it back down for a moment, because for all the speculation, the path to such a future starts with us, right here, right now. Before humanity can even dream of cosmic engineering or universe hopping, we have to survive our own. Self-made threats, climate collapse, nuclear weapons, AI risks, ecological disaster. The end of the universe may be billions of years away, but our window to reach those futures could close much sooner. If we don't make it past this century, we may never get the chance. That's why questions like these matter so much, because they remind us of what's at stake. Not just the future of our species, but the future of life, intelligence, and consciousness in the universe. The idea that we could become stewards of existence itself, that we could carry the flame of awareness through the cold void across time and space. It's more than science, it's a calling. The end may be inevitable, but what if it's just the beginning? Imagine a universe nearing its final breath. Galaxies once blazing with starlight now flicker dimly across unimaginable distances. The stars have long since died, their remnants scattered into black dwarfs, neutron stars, and ancient black holes. The background temperature of space has cooled to fractions of a degree above absolute zero. Time still moves forward, but barely anything changes anymore. This is the future scientists call the degenerate era, a shadowy chapter in the universe's long story, and it might last for trillions upon trillions of years. But here's the astonishing part. Some scientists believe intelligence could still exist during this time, not as we know it, but in radically evolved forms. Because survival in this frozen void wouldn't just require power or shelter, it would demand mastery over time, matter, and perhaps even consciousness itself. One of the most intriguing ideas comes from physicist Freeman Dyson, who speculated that advanced life could adapt by slowing itself down. In this chillingly quiet universe, Energy becomes scarce, so every spark must be conserved. A civilization might run its systems in bursts, processing information for a few milliseconds, then going dormant for centuries before reactivating again. A form of hibernation on a cosmic scale. This way they could stretch finite energy across vast time spans, trillions of years of thought and memory compressed into fleeting instants, spread out across the silence. But that's just one version of survival. Other thinkers have gone further, proposing ways in which life could detach from matter altogether. After all, if atoms begin to decay, if entropy eats away at every structure, what then? Some theorists suggest a radical concept: substrate-independent minds. Imagine uploading consciousness into digital systems, processing thought not with biological neurons, but with exotic computing substrates, perhaps even quantum fields or particle arrangements suspended in artificial space-time pockets. In this scenario, intelligence would no longer be bound by biology or even by traditional physical form. It could become fluid, adaptable, distributed, minds scattered across microscopic black holes or encoded in patterns of gravitational waves pulsing faintly through the cosmic abyss. And yet, this raises a haunting question. What is consciousness, really? Is it something that must be tied to a physical body, to a chemical brain, or can it be replicated in code, simulated perfectly by a system so advanced it feels indistinguishable from real awareness? If the answer is yes, then the death of the universe might not mean the death of minds, just their transformation. In fact, some researchers have suggested that information itself may be more fundamental than matter or energy. According to physicist John Wheeler, it from bit, meaning that every particle, every force, every law of nature arises from binary information, yes or no, 1 or 0. If that's true, then perhaps consciousness is not something that needs a universe. It could exist independently, encoded in the fabric of reality, or carried through into the next iteration of existence. Let's take this idea further. Suppose, at the edge of the universe's collapse, or its freeze, or its rip, a civilization prepares for escape. They've exhausted every local resource, harnessed every star, tunneled through space-time, and now they make their final move. Not a ship, not a station, but a message. A self-contained bubble of reality, carrying the code for life, intelligence, memory, perhaps even emotion, hurtling into the unknown. This concept is sometimes called a legacy drive, a kind of cosmic seed that holds everything a civilization once was. It could travel through hyperspace, quantum foam, or higher dimensional space. It may never reach another destination, but if even one survives, if one of these seeds finds a pocket of emerging energy, a fresh universe forming in the chaos, it could bloom again. Consciousness could rise anew, not reincarnation, not resurrection, but continuity, a thread connecting the dying cosmos to the next dawn. But maybe there's another way. What if civilizations don't escape the end of the universe, but learn to reverse it? Some fringe theorists have explored the idea of entropy reversal, a process that could reset or reconfigure the direction of time itself. This isn't just science fiction, it's rooted in deep questions about thermodynamics and quantum mechanics. If time flows from low entropy to high entropy, what happens if you could artificially reset entropy levels? Could time reverse? Could history loop? Could life re-emerge in a reversed universe, with memories flowing backward, or would it be something altogether different? And then there's the wildest idea of all. Reality is a simulation. If the universe itself is a form of computation, if space-time, energy, and particles are just emergent properties of a deeper code, then perhaps the end of the universe is no more final than the shutdown of a computer program. In this view, intelligent life might eventually meet its creator, not a deity but an architect, another intelligence running the simulation. Or perhaps, we are the architects, and one day we will build simulations that give rise to their own realities, and their own questions, and their own quests for survival. Now here's a story to leave you wondering. Imagine a future civilization, far beyond even our wildest theories. They've mapped every particle in the universe, mastered time, learned to bend the laws of physics, even created entire nested universes for experimentation. They know the end is coming, not for centuries, but within days. In their final act, they gather everything they've become and encode it into a single artifact, not a machine, not a ship, but a thought so complex, so perfect, that it becomes self-sustaining, capable of replicating itself, teaching itself, evolving forever without energy, without space, without matter. A self-contained universe, born not of stars but of consciousness itself. Is it possible? We don't know. But if the future teaches us anything, it's that we haven't even scratched the surface of what life and intelligence truly mean. And maybe, just maybe, the end of the universe isn't the end of us. It's the next level of the journey. So now that we've wandered across galaxies, tunneled through black holes, built civilizations around dying stars, and imagined consciousness reborn in the ashes of reality, let's take a moment to step back. Why does this matter? Why should anyone care whether humanity could survive the end of the universe when we're still trying to fix potholes, feed families, and keep our planet from overheating? The answer is simpler and deeper than you might expect, because how we think about the end shapes how we live today. When we imagine the farthest reaches of time, when we ask, could anything survive the end of everything? We're not just chasing sci-fi fantasies. We're reaching toward the very core of what makes us human: curiosity, hope, the refusal to accept finality. These are the sparks that have driven every great leap forward in our history, from fire to flight, from stone tools to space telescopes. And maybe that's the real secret. These grand cosmic questions don't take us away from reality. They bring us closer to it. Because if we could survive the end of the universe, if we could preserve knowledge, consciousness, creativity, and love beyond time itself, then surely we can survive the challenges of our own century. Surely we can end wars, cure diseases, protect our ecosystems, and build a world where intelligence and compassion thrive side by side. You see, thinking cosmically is not escapism, it's inspiration. When we dream of future galaxies, we start to value this world more. When we imagine uploading mines or escaping heat death, we also remember how precious it is just to hold a hand, share a story, breathe clean air, or see the stars. And in a strange way, contemplating the universe's death reminds us how alive we are, right now. But let's not ignore the stakes, because here's the truth. If humanity doesn't survive this century, all those possibilities, those Dyson spheres, those baby universes, those legacy drives, they'll vanish before they even begin. We might be the only known form of intelligent life with the potential to carry consciousness into the distant future. And we are still fragile, still on the edge. The decisions we make today, how we use our technology, how we treat one another, how we protect our planet, will echo not just through generations, but possibly through eternity. If intelligence really is the rarest thing in the universe, then perhaps our greatest responsibility is to ensure it doesn't go extinct, not just for us, not just for Earth, but for the universe itself. And here's where the story circles back to you. You don't need to build a spaceship or decode quantum fields to be part of this journey. Every time you ask questions, challenge ideas, share knowledge, you're keeping that cosmic flame alive. Every act of kindness, of learning, of wonder, every time you look up at the night sky and ask, what if? You're participating in something far greater than yourself. Because the future isn't some distant point on a timeline. It's being written every second by ordinary people in quiet moments across this tiny blue planet spinning through the void. And maybe, just maybe, the end of the universe won't be a cold silence. Maybe it'll be a whisper, one last signal echoing through the darkness, carrying everything we once were, everything we dared to become, everything we hoped could last forever. So let me leave you with a final question, one that only you can answer. If you knew humanity could survive the end of the universe, what would you do differently today? And hey, if you found yourself thinking, wondering, even feeling a little awestruck along this journey, then let's keep the conversation going. Share this video with someone who loves a good cosmic mystery. Drop a comment below. What do you think our best shot at surviving the end of time is? A simulation? A baby universe? Something else entirely? And of course, give it a like. It helps this content reach more minds who crave these kinds of deep questions, because the universe may be heading toward its finale, but our story is just getting started. Stay curious and keep whispering to the cosmos.